You ever wonder how your computer, your printer, and, your server all manage to talk to each other without just creating a massive digital traffic jam? Well, today, we're going to pull back the curtain on the unsung hero of your local network, the network switch.
I mean, just think about your office, right? When you hit print on a document, how does it just magically show up at the printer and not, say, on your coworker's screen? The secret? It's a tiny but incredibly important device that acts like the network's own personal traffic cop.
All right, so let's dive right in. And to really get a handle on what a switch does, we're going to ditch the heavy tech jargon just for a minute. Instead, I want you to picture a super efficient, almost psychic office assistant. Trust me, this one simple idea is going to make everything click.
So, at its core, what is a switch, really? Well, you can think of it as the central nervous system for all your local devices. We're talking your computer, the printer, the server, the whole shebang. It's basically the glue that holds your entire local network together, making sure all that internal communication just flows. And here's where that office assistant analogy we talked about really shines. See, instead of just shouting a message across the entire office for everyone to hear, a switch is way more like a discreet courier. It takes a message and delivers it directly to the correct person's desk, and nobody else's. And that incredibly targeted approach, that's the secret sauce to its amazing efficiency.
Okay, but how does our super smart office assistant actually know where everyone sits? It's a great question, right? Well, it all comes down to speaking a very specific language. So let's go ahead and crack the code of how a switch communicates.
Now, this is where things can get a little confusing for folks, so let's break it down nice and simple. You've probably heard of IP addresses and packets, right? Especially when we talk about the internet. But switches, they play a totally different game. They use something called MAC addresses, and they package data into what are called frames. Here's the best way to think about it. A MAC address is like a device's permanent, factory-stamped serial number. It never changes. An IP address, on the other hand, is more like the temporary address of a hotel you're staying at. It can change. Okay, and here's the really cool part. When a switch gets one of these data frames, it's basically like a piece of mail. It has a from address and a to address. But here's the genius of it. To do its job, the switch only has to look at one single thing, the destination MAC address. That's it. That's all the info it needs to deliver that message to the exact right spot.
And this is where the smart in our smart office assistant really, truly comes into play. Honestly, this is the big aha moment. See, a switch isn't just handed a directory of where everybody is. Nope. It builds its own directory. It creates a map of the entire network completely from scratch.
Right. So let's go back to our office. If a new person starts, how does the assistant figure out which desk is theirs? A switch faces the exact same challenge. When a brand new device plugs into the network, how in the world does a switch learn where to find it? The secret is something called the MAC address table. You can think of this as the switch's brain, or its internal address book. It's a really simple but incredibly powerful list that the switch builds on its own, and it just matches a device's unique MAC address to the physical port number it's plugged into.
And here, we can take a little peek inside one, is really just a simple lookup table. The switch just looks at it and says, okay, the device with a MAC address ending in 5E, that guy's on port 1. The one ending in OD, he's over on port 4, and on and on. It's simple, it's lightning fast, and because the switch builds this thing all by itself automatically, it's just incredibly powerful.
So really, it all boils down to this simple 4-step dance. First, every time a device sends out data, the switch learns its MAC address and which port it came from. Second, it stores that information in its little address book. Third, it checks the destination address on the data frame. And finally, it forwards that frame only to the correct port. That's it. No extra noise, no wasted effort, just absolute pinpoint delivery. Okay, so now that we know how a switch thinks and acts, let's zoom out a bit. Let's figure out where it fits into the grand scheme of things. And to do that, we got to talk about a really foundational concept in networking called the OSI model. Think of it as a kind of universal blueprint for how all the different network gadgets are supposed to talk to each other. See, for the pros who build and manage our digital world, the whole world of networking is broken down into 7 distinct layers. But when we're talking about switches, there's one number, one layer that is everything. It all comes down to layer 2, the data link layer. This is the switch's home.
It's where it lives and breathes. This layer is all about one thing, and one thing only: getting data from one device to another, but only on the same local network. This is its home turf.
And that's exactly why Layer 2 is the perfect home for a switch. Everything we just talked about, using those permanent MAC addresses, working with those data frames, delivering messages directly, that's literally the job description for Layer 2. And that last point on the slide, that's a huge deal. By creating these direct, private little conversations, switches prevent what we call collisions. And a collision is pretty much what it sounds like, a digital traffic jam that can grind your whole network to a screeching halt. All right, to really, really appreciate what makes a switch so special, let's put it head-to-head with some of its relatives in the big networking family. First up, we have the switch's, let's call it, ancient ancestor, the hub. A hub is like that terrible office assistant who just stands in the middle of the room and yells every single message at the top of their lungs. It gets a piece of data on one port and just blasts it out to everybody. It's loud, it's inefficient, and it creates a ton of those collisions we were talking about. Put simply, switches are smart and hubs are, well, not. And that's why you basically never see them anymore. And then we have the router. Now, this is the other device that people mix up with switches all the time. But it's really simple if you think about it like this. If a switch is your internal office mail system, a router is the main post office that connects your entire building to the rest of the world. Switches handle traffic inside your network using those MAC addresses. Routers are the gatekeepers that connect your network to other networks, like the internet, and they use IP addresses to do it. They have totally different jobs, but you absolutely need both. So what's the bottom line in all of this? It's that switches are the absolute backbone of our modern local networks precisely because they're intelligent. They actually learn the layout of their network and deliver data with surgical precision. And what that means for you is less background noise, way fewer digital traffic jams, and a much faster, more efficient network for everybody. They really are the silent, hard-working traffic cops that keep our digital lives running smoothly. And that brings us to one final, really interesting question. We've figured out that switches are like the local roads, handling all the data traffic inside our own little neighborhood network. But what about the massive global highways that connect all of these neighborhoods together to create what we call the internet? Well, that's a story for another time. Thanks so much for tuning in.